So we're going to kind of scamper through this really quickly. So the notes were quick. We really just got you set up for the activity for today, which is why you have Post-its on your table. So we reviewed evaluating composite function. So composites become a really big deal from this point forward, when we can put one function inside another. So we're really looking for grouping symbols. We're really looking for those brackets. Or, you know, if we have something in a trig function, like cosine of x squared, they might not put brackets around the x squared, they might. But we're really focusing in on those composites. Okay, we also know that so far, right, we've got our color rules, we've got our trig rules, the logarithmic, products and quotients. We don't have a rule for composites, and so we need one. And so that's what we're going to discover today. In the notes, I assigned you a specific, your pod, a specific part of the activity. So pod A, that's the front row. You're working on the red function. Pod B, you're working on the green function. That's the next row back. Pod C, you're working on this next function, and pod D, you're working on the bottom function. And then somebody's got to put the Post-its up when you have stuff done. So this is a really quick investigation. It should take about 5 minutes. And then we're going to have some examples, which should take about 10 minutes. And that should leave us a good half an hour or so for topic questions. Okay, so we did this first one in the notes. So if you didn't take the notes, you kind of luck out here. Okay, so we know that if I differentiate x to the 6th power, I get what?
6x to the 5th.
Right, yeah, we know that's true, right? We can all agree that that is in fact the correct derivative. Okay, so I'm going to rewrite x to the 6th. I rewrote it as a composite. I have x cubed in a squared function. Does that make sense? I got x, well, where's my pointer? I got x cubed here, and it's inside a square function. That's why I have the grouping symbols, the parentheses or the brackets or whatever you call them. So the first column here, so in your groups, you'll figure out, you know, you'll as a group you figure out what you did about each one of these is. And then here in this first column of differentiating, you're doing the color rule on the outside power, and you're leaving the inside alone. So for me, I'd bring down the 2, keep my brackets, and write x cubed to the 1st power, right? Reduce my power by 1. And then I'm going to simplify it. That's really just 2x cubed. And then I'm going to look at this, because this obviously isn't right all by itself. And I'm going to look at this, and I need a multiplier. I need a 6, so I'm going to need to multiply by 3. And I need an x to the 5th, so I'm going to need to multiply by total 3x squared. Okay? And so that's what you're going to go through for the 4 functions below. Does that make sense? Okay. All right. So go ahead and get started. You have 5 minutes till 10:45 to get your Post-its on the chalkboard. So back as a group, just a sec. Sorry. You're going to use a square Post-it to find the derivative as a group. And then you're going to use the rectangular Post-it to get the outside derivative, and then another square Post-it for the multiplier. And then we're going to try that a different way. We're going to try that a different way, a different type of composite with the same function. Right? We're going to try that again below and see if we can see a pattern. So we have this information for the first 2. Here's the first 2. Right, that should match what we have up on the board, which it does. Okay, so I'm gonna keep moving on. My screen just isn't that big, but that's on the board. So my last two functions look like this. And so we realize that just looking at the outside power, and doing the power rule there and leaving everything in the brackets alone isn't enough. We had to put this multiplier out here to get the right answer to match, right? 18x squared times 2x is 36x third. So where did this 2x come from? 6x squared times 6x, 36x to the third. Where did this extra 6x come from? 10x to the fourth times 4x cubed is 40x to the seventh. Where did this 4x cubed come from? Anybody see where these are coming from? Why is it trying to do this? Got it? Is there any other people seeing a pattern? No, who has to give up the pattern? Okay, so if I look here and I see 2x cubed, what's this derivative? X brings down to 3. You can do 6, x to the second power. Okay. What's the derivative here? So we're playing this game with composites. We're saying if we just look at the outside function and differentiate that, it's not enough, which should be kind of apparent. I mean, how could you just look at one aspect of a function, right? When there's a lot going on there. So we're looking at this right-hand column here and we're saying, hey, I've got an x to the fourth inside. And if I differentiate that, I get a 4x cubed. I've got an x squared inside. If I differentiate that, I get 2x. I've got a 3x squared inside. I could be going all the way back to the original one too, right? Because we're not changing the inside stuff when we do the outside derivative. I get 6x for that derivative, and so on and so forth. So we end up with differentiating twice for these types of composites. We'll actually put more composite. We'll put like a function inside a function inside a function. We're going to end up differentiating 3 times. Okay? So the idea is if I have this outside inside composite, this is a composite, right? Outside inside. I take the derivative of the outside. Now, there's an important caveat here. I take the derivative of the outside, but I leave the inside in its bracket. I don't touch that. And then I come back afterwards and I take the derivative of the inside and multiply it. Okay? You okay so far? Okay. So the idea is this, right? We started out with polynomials. That was great. We used a lot of power rule here. Okay, and then we got the trig derivative, trig functions. We're like, uh-oh, can't use power rule anymore, right? And we found out these things numerically. We made tables and drew graphs and recognized those functions. And then we did that with exponential as well, except that this middle one was quadratic, so we just talked about it on the back end. And then we said, oh, wait a minute, what if I want to start multiplying things together or dividing things? And we knew a set of rules. Okay, and then when we started the quotient rule, we could go back and talk about the functions that we didn't. And now we're just adding another piece to the puzzle. We're saying, okay, what if I have a composite? This is what I need to do. And so when I have the composite, we have this composite rule. And as we do this composite rule, we'll end up working with power rules and trig rules and stuff like that, depending upon what the functions are. So far, so good. So these are really the building blocks that will be with us for the rest of the year. So this is what we call this the chain rule. And for kind of obvious reasons, I think it's kind of like we've got this function inside a function, and we can keep going and keep going, right? We can put a function in a function in a function in a function in a function, right? And we're just going to chain those derivatives together. We're going to say this derivative times that, times that, times that, times that. We're just going to keep differentiating as we move inside that function. So it says if y is the composite f of g of x. Remember that sort of stuff from pre-calc, and I think you even did a little maybe in algebra 2. Right? This notation here is saying take function g of x and put it into f wherever you see the x. Then the derivative of y prime is the outside derivative, which is the outside function. F, right? F's on the outside. So it's the derivative of the outside, which is f prime. Okay, right? You know, what's the derivative of f? F prime. What's the derivative of g? G prime, right? Those symbolic representations. But it's the derivative of f keeping g of x intact. We're not going to touch the stuff on the inside when we do that derivative. And then we're going to follow it up on the back end with a link in the chain. Okay, outside derivative evaluated at g of x. We're going to follow that up with a link in the chain by taking the inside derivative. Doing okay? Okay, so this is where this kind of helps. Who wants to expand out 2x plus 3 to the third? I don't. Right? I don't want to go 2x plus 3 times 2x plus 3 and FOIL that out and then multiply it by 2x plus 3 again. Let's do a chain rule on this. Outside derivative is bringing down what power? Yep, we're going to bring down the 3. And we're going to leave the stuff in the brackets intact. 3 times the quantity, 2x plus 3. And then reduce the outside power to a 2. And then we got to look inside the brackets. Look at that function. What's its derivative? Just 2. So times 2. There's the inside derivative. And that is the derivative. The nice thing is we're done. No expanding, no simplifying or combining terms. That's it. We might do this. 3 times 2 is 6. Does that make sense? Okay. I don't want to FOIL that out and multiply it by 6. I don't even want to do that to the derivative. You okay?
Yeah, I'm fine. I know the times 2.
Because that's the inside derivative. The 2 is the derivative of this. 2x plus 3. Yeah. Okay. Now, I don't want you to write this down, but that's 2x plus 3 cubed FOILed out. There's its derivative. I can factor out a 6. All right, I can FOIL this out. I guess I FOIL that out, and we get the 24 and the 72 and the 54. You don't have to write any of that down, though. If you stopped here, that's great. That's all I really want you to write. Okay. Okay, let's do power rule on this. Bring down the what? Bring down the 5. Leave the stuff in the brackets alone. Write the new power 4. What's the derivative of the inside? Close. Negative 6x. About the only thing they simplify is 5 times negative 6x. I mean, this is the answer. You could put this into con, it'll correct it. If it's a multiple choice, you'll see a minus 30x out front instead. But I bet you could recognize that equivalent answer option, even without simplifying it. Doing okay so far? Okay, so this third one is a function inside a function inside a function. Okay? It's what functions do you see here? How many see a quadratic? An x squared? Way on the inside, right? What else do you see? How many see a trig function? Which one? Cosine. How many see a cubic? Something to the third power. Right? So we got three things going on here. We've got something to the third power, we've got a trig function, we've got something squared. So really, there we go. Quadratic, inside a cosine, and cubing all of that. We really have that. Does that make sense? Okay, so the cube is on the outside because that's what this notation means. Cosine cubed means take the cosine of whatever, get that value, and then cube it. Okay, so let's work on the outside. The outside function has this power, it's power rule. Bring down the 3, make that power a what? 2. So we bring down the 3. We're talking about these outer brackets here. So everything on the inside just gets copied down. Boom. Change it to a 2. That was your outside derivative. What's the next layer in? Cosine. What's the derivative of cosine?
Sine.
Okay, so we need to multiply times negative sine, everything on the inside. Right? I'm not going to climb over desks to get to the board, but we're literally talking about just differentiating this, right? Cosine to negative sine, leaving all of this the same. I guess I could do that here. Cosine, differentiating it to sine, leaving all of this the same. And now we got to come in here. What's the derivative of this inside? Times 8x. I think 3 is the most that they'll ask you to do. Okay, and as far as simplifying, 3 times minus 1 times 8x, they're going to put that out front as negative 24x. And then it's going to be a crapshoot as to what they've listed. Probably the cosine. They'll probably list the cosines and they'll put the squared back here. Okay, and then the sine, I didn't have space for it, but the sine of that. It ends up being this quite lengthy expression. Doing okay so far? Yeah, here.
15.
Ooh. Okay. I know we'll have time tomorrow to do topic questions galore, so I would say when we wrap up here, we'll just jump into the com and we'll save those topic questions for tomorrow. Oh, I guess I wrote it all out in one line. There we go. That's what it would look like. I think you get the idea though. I just didn't have the space. You doing okay so far? All right. So how do you get the correct derivative of a composite? What do you have to multiply? Yep. Times. Yeah, times the derivative of g of x, times the derivative of g of x. Okay, I don't know how you want to write that. I say take derivatives from outside to inside. Okay, and multiply them together. And every time you take a derivative, whatever's inside, you're leaving alone. Eventually, you'll get to the inside. Okay. So in your notes, I know you haven't had a chance really to dive in because I only gave you the couple of pages that you needed for notes and the activity. But there's a topic question, there's a chain rule. Tomorrow we have notes tonight, and it's more chain rule though. We gotta call it advanced chain rule. Okay, but I think it'll be short, and then we'll be able to do both topic questions. Circuits are always optional. That's just if you need more practice. And so you've got these two con for tonight. I would focus on the con, get those out of the way. I know we can do both topic questions tomorrow. This works much better when we have a full hour.